Alright, so today we're going to start talking about the precursor to finding derivatives. Right? We're going to talk about average rate of change and then instantaneous rate of change. Right? This instantaneous rate of change idea is what almost the rest of calculus is going to be based on. Right? And then we're going to use that idea of instantaneous rate of change to find slopes of curves and tangent and normal lines. We'll explain what all that means here in a second. Okay? So first, let's talk about average rate of change. Okay, the average rate of change is just the amount of change divided by the amount of time that's passed. Okay, the average that something has happened. So a super simple example, right? You went 60 miles in an hour. Your average rate of change was 60 miles an hour. But you may not have been going at constant speed of 60. You may have gone 55 at some points in that hour. You may have gone 65 at some points in that hour. But you averaged 60 miles an hour. Okay? So the easiest way to think about that, and the way that we're going to look at solving problems, is just finding the slope between a pair of points. Okay? Specifically, we can call the slope between a pair of points of a secant line. Okay? Probably remember from geometry that a secant line is just a line that passes through 2 points on whatever object we're talking about. In geometry, we talked about that with circles. Okay, but here we're going to talk about a secant line being a line that hits 2 points on the curve that we're dealing with. Okay, so visually, this is what we're talking about. If I've got this blue curve and I want to find its average rate of change from A to B, I'm just going to find the slope between these 2 points. Okay, so I don't have specific values for these. This is just kind of a general case. So I'm going to say that the average rate of change is the slope. Now, this is the slope formula that we all know, right? y2 minus y1 over x2 minus x1. I'm going to say, or I'm going to define this just a little bit differently. Not much, just a little. Okay? I'm going to say that my y's are f of b and f of a. Okay? And that's what those y values are. Right? My f of b would be here, f of a would be here. Right? So I'm just going to define this as f of b minus f of a over b minus a. Same thing as y2 minus y1 over x2 minus x1. Okay? So that's average rate of change, is just slope between 2 points. So let's take a look at solving an example of that here. Okay? I want to find the average rate of change of this function, 2x squared minus 3x plus 7, over the interval negative 2 to 4. Okay? So I don't really have to know what this function looks like to find its average rate of change. Okay, we want to find f of b minus f of a over b minus a. Okay? And b and a are the x values of the interval in question. So if I want to find the average rate of change from negative 2 to 4, well, what I'm finding then is f of 4 minus f of negative 2 over 4 minus negative 2. Okay, just like that. Does not matter if I switch the order. If I do f of negative 2 minus f of 4 over negative 2 minus 4, I will get the same exact answer. Okay, so let's evaluate each of these pieces. Okay, I can find f of 4 and f of negative 2 in this function. So if I plug in, if I plug in 4, well, we'll get 2 times 4 squared minus 3 times 4 plus 7. So we get 32 minus 12 plus 7 should be 27. Then if I evaluate f of negative 2, plug in negative 2, and we get 4, 8, plus 6 plus 7, so 21. Okay, so we have all of the information we need now to plug into this formula. Okay, I know that f of 4 is 27. I know f of negative 2 is 21. So that's like my y2 minus y1. Okay, but we're saying that that's f of b minus f of a over, and we already know that my x values, b and a, are 4 and negative 2. So just do the arithmetic now. So we get 6 over 6. My average rate of change on the interval negative 2 to 4 for this function, 2x squared minus 3x plus 7, is 1. Okay, what that's saying is if I drew a line between these 2 points on the curve, between an x value of -2 and an x value of 4, my line would have a slope of 1. All right, in the next video, we're going to take a look at instantaneous rate of change.